All right, here we're in chapter 4 on analyzing change, applications of derivatives. So we're looking at 4.3 right now, and this is absolute extreme points. So an interval is said to be a closed interval when it contains both of its endpoints. So, if we have the interval from here to here, it's going to be closed if it contains that point as well as that point and everything in between. Now it's noted as that. So instead of parentheses, we're actually going to include those things. And so it's going to actually be a bracket. But we usually are used to putting things in parentheses to make a interval. But this time the interval has to include and therefore the brackets. And it's drawn with filled in dots at either end of the graph. So if we're doing a graph, maybe, we'll have something like that. So that was to show that it includes its endpoints. Now, although the endpoints in an interval can never be relative extreme points on a closed interval, endpoints can be absolute extreme points. So, in this case, it looks like they're both the same. So they'd be both absolute minimums, whereas this would be the absolute maximum. Okay. And any interior point can be both a relative and an absolute extreme point. So in that case, this one's the absolute max as well as the relative max. Okay. So absolute extrema, what are they? Well, a function f has absolute maximum at an input c if the output fc is greater than or equal to every other possible output. Okay. Now, likewise, a function f has an absolute minimum at an input c if the output fc is less than or equal to every other possible output. Now, the output f of c is referred to as the maximum or the minimum value of f. And so, when these are both the same, that's going to be the minimum value of f. And up here, that's going to be the maximum value of f. So those are why those are absolute extrema. Here are some examples using graphs. Here we can have multiple places where we have different minimums. Now, this is a relative minimum because it's not the absolute minimum, because the absolute minimum is going to be the very least one. It's also called the relative minimum as well as the absolute. So that kind of helps it, set it off from everything else. Now, here we have a relative maximum. And this is going to be the relative maximum as well as the absolute maximum. So if we had circled those in here and here, those for sure then make that one the absolute maximum. Now, the same thing would go here. This would be a relative min. This would be a relative max as well as the absolute maximum because there's nothing that's higher, okay? And then this is going to be the relative min as well as the absolute min. Okay. So kind of like I drew in that first picture, absolute extreme can occur at more than one input value on the interval as shown below. So we can have an absolute maximum at this point and this point if those are equal, okay? And before, what did I draw? I drew the parabola and I did absolute minimum where they were equal here, okay, here, and here. So those were absolute minimum and they were equal, same point, okay? Now, all points on the interval below are both absolute maxima and absolute minima because that's a straight line. And so it's going to be the absolute maximum and absolute minima of this function, okay? Now, notice again, we have our endpoints are filled in with circles. And so that's a kind of a key when we really want to find that absolute maximum. Now, finding an absolute extreme on a closed interval. How do we do it? Well, to find them, either maximum or minimum of a function on a closed interval from A to B, and that's the key thing. We're going to be looking at intervals. And so, the curve might do something like that, and we're only going to look at the interval from maybe here to here. Well, from here to here, this then is going to be our absolute minimum. And between those 2 points, this one looks higher. So since it's going to be a closed interval, that's going to be the absolute maximum. And this is just going to be a relative max. So looking at intervals is going to be different than looking at the actual whole graph. So we're going to find all relative extreme of f in the interval. So, in the interval, we have this is min, that's a max, that's a max. And then we're going to compare the relative extreme values in the interval with f of a and f of b, the output values of the endpoints. So we're going to look at all the endpoints and then any um, minima or maxima between those, and then find out which one is the smallest and which one is the largest, and that's going to be the absolute minima and the absolute maximum. Now, unbounded input and absolute extrema. What happens then? Well, when the input interval is not specified or it's unbounded, it goes to infinity, it's possible that the absolute extrema do not exist. So, for example, If we have the function f of x is equal to e to the x, that has no absolute maximum f of x when considered over all real number inputs, okay? And that's because the limit as x goes to infinity of e to the x, well, that's equal to infinity. So no matter where we go, we can keep going up and up and up and up and up, and it's going to keep going forever up there. And so there's not going to be a maximum ever, okay? Now the function, same one, has no absolute minimum when considered over all real numbers because this way it's getting closer and closer and closer to zero. Never reaches it, but it gets very, very close. And so it actually never reaches that limit of zero. Okay, so it gets close, but it never reaches it. So this, when unbounded, going from negative infinity to positive infinity, are not going to have absolute maximum or minimum values. Now, how do we find it without a closed interval? Well, to find the absolute maximum and minimum of a continuous function f without specified input interval, what we're going to do is we're going to find all relative extrema of f. Then we're going to determine the end behavior of the function in both directions to consider a complete view of the function. Now, the absolute extrema either do not exist or are among the relative extrema. So that's going to be the key. Okay, and so we'll see that in examples here in a little bit. But we're going to find lots of different, extrema, absolute, relative, whatever, and how to get to those. Okay, so that's going to be one way. And so what we're up to now is we're actually going to start looking at the actual examples. So I'll stop there and I'll come back with examples.